जैसा हमने एक्सपेक्ट किया था, द क्वेश्चंस इन बायोकेमिस्ट्री इन current exam INICET was completely conceptual and clinical, and was integrated also. Not only there was integration with clinical subject, there was also integration in between the pathways, right? So as for example, if I discuss you one question which was asked in this exam INICET, this question was asked: ketosis is common in type 1 diabetes, and it was multiple answer type of question. The correct statements in this question was increased fatty acid mobilization from adipose cell, decreased entry of acetyl-CoA in the TCA cycle, and increased beta hydroxybutyrate synthase. So these options were correct options, and this was the wrong option. So for solving this kind of question, you need to know the complete knowledge of diabetes, the biochemical alteration which is there in the diabetes, and how that hormonal profile which is changed in diabetes is affecting the ketogenesis. So let's discuss this concept now. When we talk about diabetes, especially type 1 diabetes, there is absolute lack of insulin. And this lack of insulin activates one enzyme in adipose cell, and that enzyme is hormone sensitive lipase enzyme. Hormone sensitive lipase. Where is this enzyme found? It's found in the adipose cell, within the adipose cell. This is adipose cell, and within adipose cell you find this hormone sensitive lipase enzyme. You should know that this enzyme is active in phosphorylated form. The covalent status which is required for its activity is the phosphorylated form. So once phosphorylated, this enzyme is active, and it's a CAM dependent phosphorylation. So when there is lack of insulin, there is upper hand of glucagon, and what this glucagon is going to do? This glucagon is going to produce cyclic AMP, which will phosphorylate certain enzymes. This hormone sensitive lipase is one of those enzymes which is undergoing phosphorylation in a CAM dependent manner, and because of its phosphorylation it gets activated. And if you talk about the role of this hormone sensitive lipase enzyme, the catalytic activity of this enzyme, this hormone sensitive lipase enzyme is doing the lipolysis, doing the cleavage of this acyl chain from triacylglycerol, and this acyl chain, that is fatty acyl chain, comes to the plasma after action of this hormone sensitive lipase. So when do you expect this fatty acid acyl-CoA in the plasma? In case of lack of insulin, which is seen in diabetes, which is seen in starvation. So in lack of insulin due to action of hormone sensitive lipase, the acyl-CoA is mobilized to the plasma, and once the level of fatty acyl-CoA in the plasma is beyond 10 millimole per liter, what happens? This starts entering the cell, and the liver is the predominant organ which is going to utilize this mobilized fatty acid. And this acyl-CoA, once it enters the cytosol, its next target is the mitochondrial matrix, where it is going to enter through carnitine shuttle, and there it undergoes beta oxidation. And fatty acid beta oxidation is resulting in formation of lot of acetyl-CoA in the mitochondrial matrix. And you know, acetyl-CoA is a 10 carbon compound, which is 2 carbon compound, which is going to enter in the TCA cycle, giving you 10 molecule of ATP. So that is the future of acetyl-CoA, which is coming from fatty acid beta oxidation, that it's going to enter the TCA cycle, and there it is utilized for purpose of ATP generation. But please understand, when we talk about the coenzymes of TCA cycle, that is NAD and FAD, the amount of NAD and FAD are limited in a cell, and there occurs a time when all the NAD is converted to NADH and FAD is converted to FADH2. So that stage when a lot of acetyl-CoA is utilized in the TCA cycle, the surplus acetyl-CoA cannot enter the TCA cycle due to lack of these co-substrates or coenzymes. So in that case, this acetyl-CoA is diverted for making of ketone body. So when there is generation of ketone body in the liver mitochondria? When there is excessive fatty acid beta oxidation resulting in formation of lot of acetyl CoA, which has saturated the TCA cycle, and that surplus acetyl CoA is going to divert for ketogenesis. Right, so this is how this process is taking place. So this is the whole concept behind it. The fatty acid is mobilizing from the adipose cell and it is getting oxidized in the liver, where in the mitochondrial matrix it is diverting for ketogenesis if there is excessive amount of acetyl CoA, which is not going to enter in the TCA cycle because the co-substrates have have converted themselves to reduced co-form NADH and FADH2. So the ketosis is common in type 1 diabetes. So it is the right statement. I mean, the lack of insulin is the reason behind it. And it is not decreased fatty acid beta oxidation. It is increased fatty acid beta oxidation, which is responsible for ketogenesis and mobilization of fatty acid, decreased entry in the TCA cycle. And as far as this enzyme is concerned, beta hydroxybutyrate synthase, what this enzyme is doing? Beta hydroxybutyrate synthase. This enzyme is the enzyme which is a reversible enzyme converting acetoacetate to beta hydroxybutyrate and vice versa. Right? So the during ketosis there is excessive activity of this beta hydroxybutyrate synthase enzyme. So that is also the true statement. So we have these three statements as a correct statement in this question. So now you can see they're not just asking you one question here. They're asking you multiple concepts in one question. They're asking you when the mobilization occurs. They're asking you when the ketogenesis occurs. They are also asking you what is the future of acetyl CoA in the TCA cycle, how long it can go in the TCA cycle. So that concept also you should know, that acetyl CoA is preferring TCA cycle to go and get oxidized there so that the ATP is produced. But if the saturation of TCA cycle is there, when the co-substrates NAD and FAD are already converted to NADH and FADH2 and they're not being tackled in time in the ETC, because the rate of ETC is slower than the TCA cycle. So what happens, there is accumulation of lot of NADH and FADH2. That moment there is diversion of acetyl CoA for ketogenesis. So this is how you need to learn, and we have been teaching you day-to-day basis in this manner that conceptual learning of the subject is very, very essential. So now you have seen that in this exam and future upcoming exams, all the concepts will be integrated, and you have to